All right. Okay, quadratic functions. Any of you know what a quadratic function is?
For something.
A for something? All right. Today we're going to talk about quadratic functions. Just a little brief intro on how they're used. This application that we're going to see today, we're going to deal more with when we deal with our word problems. All right, so today we're going to get a brief, like how they're used, and then we're going to learn how to graph them. All right, so we're going to pretend you're taking a trip this summer and you're trying to save up money now. And to save up money, you're selling pizza by the slice on campus. You got permission from the school, they okayed it, and you go out and you purchase your pizzas and you come to school and you sell them by the slice. All right, so this right here, this x-axis is going to represent the price per slice. And this is going to represent what? If this is your price per slice, what is this going to represent? This is your price per slice, how much you're charging, the money you're going to make. All right. Whoa, what? All right, so you go out and you purchase the pizzas.
Yeah.
We're going to start at the origin. This is not something you would do, but we still need to figure out what would happen if you did. No, because I'm recording. Okay, so if you're at the origin, that means you're charging $0 per slice. So you buy the pizza and you come out and you're charging $0 per slice. Are you going to make money?
No.
Are you even going to break even?
No.
Are you going to lose money?
Yes.
All right, so we're just going to put a dot down here for losing money. All right. So you charge 5 cents per slice, 10 cents per slice, 50 cents per slice. What does this represent right here when I'm on the x-axis?
Even.
Breaking even. You're right. All of this down here is you're losing money. Do you agree? What does that mean as far as your price per slice? You're charging too much or not enough? Not enough. At this point right here is where you break even. Is that where you want to be? No, because it's pointless. You're breaking even. All right. So you start to charge more, and as you charge more, you realize you make more money. Yes? Okay, does that mean this is linear? That you can charge $10 or let's say $9 per slice and make a whole lot of money? Okay, so are you going to make a whole lot of money? What's going to happen if you're charging $9 a slice? No one's going to buy you. You're going to end up what? Losing money. You're going to be back down here. Okay, so you will go up, but there will come a point where you come back down. Do you agree? And then you end up back at the negative. Okay, so when you trace this, you'll notice it is a U shape. In this case, an upside down U shape. We call that a quadratic function, otherwise known as a parabola. Yes. All right, quadratic function, otherwise known as a what? Parabola. So when you hear parabola or you hear quadratic, you know that those two things are the same. All right, so let's talk a little bit about this graph. I'm going to put here, let's say that this is $2 per slice. So what happens, okay, first off, what does this represent down here? We talked about it already. This represents making money, losing money, or breaking even? Losing. You're either, this represents you're charging too much or too little? Too little, and over here you're charging too much. Okay, what do these 2 points right here that I'm pointing to represent? Breaking even, otherwise known as the x-intercepts. And what does all this up here represent?
You're making money.
You're making money. All of this is making money. You want to be anywhere up here. Where's the best place to be? Top there, right? Because that's where you're going to make the most money. Do you see that?
Yes.
All right, so this point right here is called the vertex. In this particular problem, because it is the highest point, it's also called the maximum. Bless you. Now, when companies put a price on their cell phones, on their shoes, on their hamburgers, or whatever they are selling, They don't randomly pick prices for these items. Somebody comes in and mathematically figures out the best price to charge. And they figure this out with a function, a quadratic function, figure out the price, and we will do this eventually when we do our word problems. And they figure out the price and they say, okay, if you charge $2 per slice, you're going to make the most amount of money. Now, you might think, well, if that means if I sell them a little bit cheaper, I'm going to sell more. Now, are you still going to sell? Are you going to sell as much? No. And again, you might think, well, if I charge just a little bit more, maybe $2.50, I'm going to make even more money. Is that the case? No. So there is a place where for a certain price, you're going to maximize your income. And that's where businesses want to be. Does that make sense? Yes? Again, we'll deal more with this when we get to our word problem lesson. That's not today. Today we're going to learn just how to graph these. All right. What is a parabola? Let's take a look. We're going to go ahead and graph one. Y equals x squared. Y equals x squared. All right. Is this a monomial, binomial, or trinomial? Monomial, binomial, or trinomial?
Trinomial.
Monomial. Because it has only one term. Do you remember the lesson where we wrote down quadratics and cubics? Do you guys remember that? Right here. Degree 1 was linear, degree 2 was quadratic, and degree 3 was cubic. So quadratic, you may not have known what it was then, but now you know it's a parabola shape. Gentlemen, I need you listening. Okay, so when the degree is 2, it's a quadratic. And if you have forgotten, what is degree again? The value of the largest exponent. I only have one exponent here. The degree is 2, so it is a quadratic. And we're going to figure out how to graph. All right. You will be given a T-chart on all of them today. Eventually, we will learn shortcuts. But for today, it's T-charts. And I will give you the values for today's assignment. All right, the middle is where we're going to show our workspace, and then this is going to be the answer. All right, y equals x squared. What am I plugging in for x on this first problem here? And I always put them in parentheses. Whenever you're plugging things in for x, always put parentheses, especially if there's a square, so you can keep track of positives and negatives. All right, -2 in parentheses is -2 times -2 when it's squared. So what is -2 times -2 equal? 4. Can anybody tell me what that would be as an ordered pair? That's x and that's y. How would I write that as an ordered pair? -2, 4. Good. All right, next one. What do I plug in for? Okay, he said -1 to the second. Do you guys agree? And what's -1 times -1? 1. As an ordered pair, how would I write that?
-1, 1.
Okay. Next one, I'm going to square what number? 0. And 0 times 0 is 0. What is that as an ordered pair? 0, 0. All right. What are we plugging in for this next one? Not always, because what am I plugging in right here? 1. And 1 times 1 is 1. So I'm going to end up with 1, 1. And what's the last number that I'm going to square?
2.
2. And 2 times 2 is 4. So 4, 2 or 2, 4?
2, 4.
2, 4. Okay. Questions? And this is, yes, this is how we're going to get the parabola. All right, so let's go ahead and sketch it now. All right, everyone have their X and Y axis drawn out. You will be given graph paper today for the ones you're graphing. All right, how do I graph negative 2, 4? Which direction do I go first from the origin? Up, left, or left, up? Left 2, up 4? Left 1, up 1? 0, 0. Right 1, up 1. Right 2, up 4. All right, now, right now you may think, oh, I'm going to make a V shape. It looks like a V. If you were to plot more points, the more points you plot, the more it would look like a U shape. So we know it should be a U shape. So when you connect your dots, make sure you're making it as a U. Dakota, head up off the desk. All right. Any questions? There's some information I did not give you earlier, and I'm going to put it now. These are words you will need to know for this lesson, for the final as well. Domain and range. Domain is the set of all X values, and the range is the set of all what? Y values. Domain is right and left because that's your x-axis, and range is up and down, that's your y-axis. All right. Let's talk about this graph in bits and pieces. This here is called the what again? It starts with the V.
Vertex.
Vertex. It has another special name as far as maximum and minimum, and it's never going to be both. On this one, it was a maximum, and you can see that it is the highest point on your graph. Can you visually see that that is the highest point? And it makes sense that it's the maximum. There is no other point higher than that one.
Nope.
Would this one be considered a maximum or a minimum? Minimum, because it is the lowest. There is no point lower than this one, so that is called the minimum. Is it possible for a parabola to have both a max and a min at the same time?
No.
It's either maximum or minimum, never both at the same time. Got it? All right, another special piece of this graph is this right here. This is called, people will call it the line of symmetry or the axis of symmetry. Because parabolas are symmetric, can you see that? 4, 1, 0, that when you go right and left, you're going up the same distance. Right 1, left 1, we went up 1. Right 2, left 2, we went up 4. It is symmetrical on the axis of symmetry, meaning you can fold it on that line, and it's going to be an exact copy of itself. Make sense? All right, so here's the kind of questions I'm going to ask you on homework today. That is an arrow. Vertex, blank, domain, blank, range, blank. All right. Vertex, I already pointed to it. What is that as an ordered pair? 0, 0. If they give you just a T-chart, and that will happen eventually, like they'll just give you that and they'll ask you, what is the vertex? Can you tell that it's 0, 0? I mean, you would have to plot them, but can you tell that it's either your lowest point or your highest point, depending on the parabola? All right, domain. I'm going to talk about range first, and then I'll talk about domain. Range is the set of all what values? Y. Y-axis. Does my graph go up and down forever? I'll repeat the question. Does it go up and down forever? No, it's only going what direction forever? Can you guys see that it's only going up forever? Yes or no? All right, so we would say range is a set of all y values, so we use the y variable. And going upwards would be greater than or less than. So we say greater than or equal to, and from what y value does the graph start to go up from? I'm going to repeat that. From what y value does the graph start to go up from? 0. I need you guys listening. Adam, get your head up off the desk. Okay, I'm going to repeat that. The range is a set of all y values. Do you guys agree that there's no graph down here on the negative side? Would you guys agree with that? Looking at these numbers here, your y numbers, are they all positive? Is there any way I can plug a number in and get a negative out when I'm squaring it? Is there any way to get a y value that's negative? No, because any number that I square is going to come out to be what? Positive. So can you see that the restriction for our range is only the positive numbers? Y is greater than or equal to 0, yes or no?
Yeah.
Yes? All right. Domain. Domain is the set of all what values? X. X-axis runs which way? Does my graph go right forever and left forever? Okay. Does this graph like go straight up? No. What is it going to do forever? It's going to gradually get wider and wider. That's what's happening off to infinity. We only drew a small segment of it, but there is no point where this parabola just shoots straight up. Do you see that? For example, 1, 2, 3, 4. What happens if I were to plug in 5? What's 5 squared? So do you agree it's going to continue getting wider? 6 squared is 36. 8 squared is 64. It's going to continue getting wider forever and ever and ever. Okay, so we say all real numbers. Shorthand for all real numbers looks like this. So you don't have to write out all real numbers every time. I'm going to write what it means, all real numbers. Or double bar R is what I call it for the shorthand. So when you see this, you need to know it because it is. I'm going to write this quite often. What does this notation represent? All real numbers. Shorthand. We have a lot of shorthand in math, so we're not writing all these big paragraphs for everything. All real numbers, that's the shorthand notation for it. Got it? So when you see it, all real numbers. Questions? I had a kid ask, does that mean there's fake numbers? No, but there are imaginary numbers, which we will deal with later in the unit. Okay, questions here. All right. Number 2. Y equals negative x squared. Bless you. Hmm? Another one after. No. -2, -1, 0, 1, 2. Who said that? That is correct. Well, I'll tell you right now what he said after we graph it. All right. Now, guys, really quick, when you're squaring x, the way this is written, are you also squaring the negative or just the x? I'm going to ask that question again. I need everybody looking at the screen. The way this is written, and am I squaring just the x or the negative as well? Let me show you another way it could be written. One of these is squaring the negative, one of them is not. Which one is this doing? This one's squaring the x and the negative, and this one is squaring only the x. Do you guys see the difference between these two? Okay, so when I work this out, I'm going to put parentheses, a negative parentheses squared for each one of them. Remember, I talked to you guys about using parentheses. Make sure your negative's on the outside. The reason is because when you plug things in, kids will say, oh, this, when I plug in 2, it's -2 squared, which is +4. That is not correct. That's not how you do it. Okay, so let's plug in -2. Order of operation. Do I cross those two negatives out first, or do I do the exponents first? Exponent. So what's -2 times -2? positive 4, and what's the opposite of positive 4? Okay, do you see what's happening? All right, so you square and then take the opposite of x squared. We're not squaring the negative. All right, next one, when I plug in negative 1, do I cross out the two negatives first or square first? Do I say two negatives make a positive, or order of operation I square? Exponents come first. And I can tell some of you are not paying attention. You are going to hurt come test day, so please make sure, or even the quiz on Monday. What's negative 1 times negative 1? Positive 1, and then we take the opposite, and what does that give me? All right, what am I plugging in for the next one? 0, 1, 2. I want you guys working those three out right now. Go. I should say we've been writing stuff down. Adam, let's go. Hustle. What's this one here? Is opposite of 0 squared is just 0. Yes. Thank you for asking. All right, this next one, positive 1 or negative 1? Negative 1. You square the 1 and then take the opposite. 2 squared is 4. What's the opposite?
Negative 4.
All right, do you guys see how that works? All right, I'm going to have you quickly make your ordered pairs. X before Y. Jaden, I'm going to have you give me the ordered pairs. I'll start you off with the first one. Negative 2, negative 4. Give me the next set. Negative 1. Okay. Bless you. 0, 0. And then, perfect. All right. And now go ahead and plot those points if you haven't plotted them already. When you make your coordinate plane, I'm going to have you make it like this. Again, you should be plotting. All right, so this is what I have. Negative 2, negative 4, negative 1, negative 1, 0, 0, 1, negative 1, and 2, negative 4. Did everybody end up with that? Connect and make your U shape, not a V shape. And what do we call this? That starts with the V. And it's either a max or a min. Which one is it in this case? A max. Why is it a max?
Because the vertex is at the very top.
Because the vertex is at the very top. It's the highest point. There is no point higher. Do you agree? I'm going to put it back. Do you see that this is the lowest point? So it's the minimum. This is the highest point, so it is a maximum. Do you guys see that? Can anybody tell me why the difference between number 1 and number 2 graph? The graphs, what's difference about?
It goes down.
Okay, they're both U-shapes, but this one's opening down and the first one was opening up. Why is that? Anyone know, looking at the equation? Positive x squared is opening up, where the negative x squared is opening down. What can we conclude about all parabolas that open downward? They have a what? Max or min? All parabolas that open downward will have a max, yes or no? What can we conclude about all parabolas that open upward? They will have a what? Minimum. And what determines whether they're opening up or opening down? Positive x squared or negative x squared. Questions? Oh, we forgot to do the side work. Let me do that now. Vertex, domain, and the range. I already pointed to the vertex up here. What is it as an ordered pair? 0, 0. Okay, domain is the double bar R. Why? Because is the graph, even though we can't see it in our picture, do we agree that it's going to get wider and wider forever? Like as it goes off to infinity, it's going to get really, really wide, yes? For example, if you plugged in -10, what's -10 squared? 100. The opposite of 100 is negative. So you'd be way down here, so you'd go over and down. It's going to get wider. It's never going to go straight downward. All right. Domain, what does this double bar R stand for? What does it mean? What is it? All real numbers. All right, range is not going to be all real numbers on any parabola ever. Is this parabola opening up forever or down forever? Down. So would I say y is greater than equal to or less than equal to? Less than equal to is downward. And what y value does it start going downward from? From what? 0. All right, one more, and I'll get the worksheets out. Number 3. I know. Y equals 2x squared plus 3. Y equals 2x squared plus 3. A monomial, binomial, or trinomial? Why is it a binomial? Two terms. Linear, quadratic, or cubic? Quadratic, because the degree is 2. All quadratics have a degree of 2, and that's what we're dealing with this whole unit. All right, making our T-chart. -2, -1, 0, 1, 2. Now remember, like I've said before, when you plug it in, put parentheses in there. I'll do the first one with you, and I'm going to have you do the rest on your own. Okay, what am I plugging in for the first x? All right, order of operation. What would I do first? Multiply to a -2 or exponents -2 squared? What's -2 squared? What's -2 squared?
4.
4. So I have 2 times 4 plus 3. Order of operation, what do I do next? 2 times 4 is 8 plus 3 is 11. I'm going to have you continue. Do the rest. Do the work. Pencils are in your hand and you're working. Guys, you're working. You should not be talking. Working.
It's not hard. I can't finish.
2 months. 2 months.
Not recently. All right.
Why would be 10 times better is so cool. But
Was it history? Did I say hard for you?
there's a channel that they dug out for the bigger boats.
It is
And
bullshit.
then there's like light blue. Light
I have to do
blue
another one?
water that's like clear and
What the
stuff.
hell? What do we need this for?
That's cool. That's nice. All right, guys, quiet down and have a seat. Now, Adam, I don't know where you're going, but come back to your seat. I have about 2 people out when they come back. Shh. Guys. All right, -1, 0, 1, 2. All right, and you work it out. Did anybody have it for this one here?
5, 3, 5.
Hold on. 5, 3.
5, 11. Whoa.
No.
You're off.
Oh, I put the 5 in the wrong spot. Thank you. 5, 5, 3, 5, 11. Is that what you guys got? Yes? All right. Hey, stop the talking. Shh. And it helps, guys, if you pay attention. Those of you saying, I have no idea what's going on, it doesn't help you one bit when you're not paying attention.
Me? Yeah. Is that Miss Torres?
What?
What?
Bradley. Bradley's like a magnet.
All right. What? I can hear you. Yeah. All right. -2, 11. Left 2, up 11. Do you guys agree? Yes or no?
Yeah.
-1, up 5. 1, 2, 3, 4, 5. Shh. 0, up 3. 1, up 5. 2, up 11. And you make your V shape. I'm sorry, U shape, U shape. Shh. Guys, pipe down. Vertex, domain, range. Gentlemen, enough. Go.
You have bubbles in your stomach.
All right. Guys. Okay. Vertex. Do you guys agree this is the vertex right here? Is it a maximum or a minimum?
It's a mini.
It's a minimum.
Mini?
All right. What is that ordered pair? Does everybody see that? What is this ordered pair? Does everybody see that it's 0, 3?
Yeah.
Domain, x-axis, you're listening. Domain, x-axis. Does my graph, even though it looks narrow and thin, does it still get wider from the right and the left off to infinity?
Yeah.
So we'd say all real numbers. Double bar R. Range is the y-axis. Does the graph go up and down forever? It's going which direction?
Just up.
And since range is the y-axis, we use y. And up is greater than equal to or less than equal to? Greater than equal to, at what point does it start going up from? From the 3. Do you guys see that? 1, 2, 3, and then it starts to grow in the upward direction forever. Gentlemen, I need you guys to stop the talking and you're listening. Okay. Questions on the vertex, the domain, or the range? Okay. Now, I will tell you this. If your parabola looks just like this and there's no restrictions anywhere, will your domain always be all reals?
Yep.
Yes. Now, there will be some rare instances, and it will come up on the test, where they draw the graph for you. They draw the graph for you, and they don't put arrows, they just put dots like this. If those two, you're not changing yours, because I'm going to put back the arrows. If the graph looked like this, they graphed it for you, and they gave you this. Does that graph go upward forever? No, because those two dots stops it. So would you still say your domain is all reals? No, because it stops here, and that's what X value?
What?
-2. It starts there, and it ends at what X value? So what would you say about your domain? Your domain is between what two numbers? -2 and +2. What would you say about your range? Your range is in between what two numbers? 3 and 11. Okay, there will be questions like that. So if it has dots and not arrows, what is your domain between what two X values? -2, +2, and between what two values for your range? +3 and +11? All right, well, I'm going to put back the arrows because that's what we had originally. All right, questions?